Welcome to the class, my dear students. In the previous couple of lectures, I have explained you about the conditional probability, total probability and Bayes theorem, where to use Bayes theorem and where to use the conditional probability. Few more problems to get clarity about these concepts of conditional probability and Bayes theorem. In today's lecture, I would like to explain you. So in a certain town, let us read this question. In a certain town, 30% of the residents own dogs, 20% own cats, and 10% own both dogs and cats. If a certain resident owns a dog, what is the probability that they also own a cat? So, what was given? Let us write down one by one. Resident owning a dog is how much? It is 30%. 30% means 0.3. And probability of owning a cat is 20%, means it is 0.1. Next, probability of getting dogs and cats, which is 10%, which is again it is 20%, so it is 0.2, and dog and cat, it is 0.1. So this is what given. And now, if a resident owns a dog, try to understand what is there are two events, that buying a dog and buying a cat. So what was happened first? Owns a dog already. What is the probability that they also own a cat? So this is what asked in the question. So it is the nothing but the conditional probability. P of C given D, which is given by the formula P of C intersection D over P of D, and we know what is P of C intersection D, which is 0.1, over P of D, which is 0.3, and that gives you around 0.333 something. So this is what the probability of that they own a cat given that they own a dog. Let us now see this problem, try to understand. Let us have a read about this question now. In a certain town, 30% again have own dogs, 20% own cats, and 10% own, try to understand this question. Dog also own a cat. What he meant by, there is a sentence difference between 10% own both dogs and cats. It is very much clear that at D intersection C it is. But in this question, try to understand, 10% own a dog, they also own a cat. That means what? Own a dog is already, he has got a dog. Now he wants to own a cat. That probability is 10%. So there is a difference between those two. So let us now take what is the probability of dog is 30%, that is 0.3 already given. And what is the probability of a cat is 20%, that is 0.2. And then what is the probability that he has already owned a dog? So we are now want to buy a cat. So that percentage is given as 0.1. Understood? Now find the probability that the randomly selected owns both a dog and a cat. Whenever you say both a dog and a cat, what is the probability of that? Means what is the first question is P of what is D intersection C is how much, is what he has asked you. So what is P of D intersection C? How to find out this? That is by using the formula, right? So what is P of C given D according to the conditional probability definition? That is P of D intersection C over P of D. So this is what the conditional probability. So what is D intersection C? We don't know. P of D intersection C over P of D is 0.3, and that is given by P of C given D is 0.1. Therefore, what is the probability of D intersection C is 0.1 times of 0.3, which is 0.03. So that is the P of P intersection C is over now. Let us now go to the second question. Let us see what is this now. What was asked? If a resident owns a dog, what is the probability they also own a cat? So what is the question he has given you? What is the probability that they owns a cat? Find if the resident owns a dog. What is the probability that they also already own a cat? So this is what asked in the question. So you can say that what is probability of D given C? Is D intersection C over P of C. So this is a conditional probability only again. P of D intersection C is what? P of D intersection C is what now? It is 0.03 over P of C. P of C is 0.1. So 0.03 over 0.2, it is what? 0.15. So this is what the conditional probability. Is that clear, all of you? Now, a real life example I wanted to take. Try to understand this. All of us, our every day to day life, we will be getting so many emails, and we will be sending so many emails, of course, but there will be many spam emails are there. So this is where we are using the conditional probability and Bayes theorem, total probability also. Try to understand. If 20%, let us read this question now. 20% of all the emails are spam. So there is 20% of the emails are spam. The probability that the system correctly identifies a spam email as the spam is 95%. The probability that the system is correctly identifies a non-spam email as a spam is 10%. So now, how the scenario now can we express this as, let us have, there are two events where you have spam and non-spam events, correct, in our mails. And in that, how many mails are non-spam? 20%. Let us have some 20% is, this is what the spam, let us say. This is spam where you have 20% is spam. So this is yes, and the remaining is non-spam, right? The non-spam means what? S complement, let us say. So now this is 20% means this is 80% is non-spam, correct? And now what was given? The probability correctly identifying that the spam email is a spam is 95%. So there is a system where how to identify that the spam email is a spam, correctly identifying. That means what? Let us have a look about this one now. Let us have like this, suppose, where this is what actually is given by, it is correctly identifying that. Correctly means, let us have correctly identifying that it is a spam. Correctly identifying that it is given that it is a spam, and it is identifying that it is correctly identifying that it is a spam. So P of C given yes, and this is how much? It is 95%. So what was given here? First thing is probability of the spam emails is 20%. 20% means 0.2. Okay. So that what is probability of complement of yes? It is 1 minus 0.2, which is 0.8. Probability of, that is why 80% here I have written. And now what is the probability of that it is a spam and it is identified also as correctly it is identified as the spam is 95%. That means it is 0.95. So this is also given. Now what is our job? The probability that the system is incorrectly identifies a non-spam email as a spam is 10%. So what is meant by that? It identifies that a non-spam event, it is a non-spam event was given email, but it is correct identifying in a non-spam email. So what do you mean by that? It is given as 10%. So 10% means it is 1 over 10, so it is 0.1. Correct? These are the given conditions he has given you. So now we have to find out, first of all, what is the probability that classified the spam by the system, and what is the probability that it is actually a spam. So how to show this? That's the question actually asked. So it is actually a spam means, given that it is actually a spam, so what is the probability that it is classified as a spam by the system, given that it is a spam? So like this is what he has asked you to find out. So now according to the definition, what is P of S given C according to Bayes theorem? It is C given S multiplied by P of S, the probability of the spam, over probability of correctly identifying that it is a spam. So now how to do this? So to do this, first of all, there are two things happen for this correctly identifying and C given S and C given S complement also. So what is the correct identification of P of C is given by P of C given S multiplied by P of S plus P of C given S complement multiplied by P of S complement. So what is P of C given as 0.95. What is P of S? It is 0.2. What is P of C given S complement? 0.1. And what is P of S complement? 0.8. So this is what actually it is the total probability. It is the total probability. And let us do this calculation to get the solution here. It is 95 2s are 190. So it is 0.19 and it is 0.08, correct? 0.08 plus 0.19 gives you 0.27. So this is what the probability of correctly identifying whether it is spam or non-spam. If it is spam, what is the probability of S into C given as? If it is non-spam, probability of S complement into multiplied by probability of C given S complement. So we got the total probability. Now we are going to the Bayes theorem. What is the Bayes theorem now? It is P of S given C is given by P of C given S multiplied by P of S over P of C. What is P of C? C given S into P of S plus P of C given S complement times of P of S complement. So this is what the total probability, the Bayes theorem gives you. So we know what is P of C given S into P of S. That is what we have already identified, which is 0.19 over. And the total probability is what actually? P of C given S plus P of C given S plus P of C given complement is 0.27. So 0.19 by 0.27, it is how much? It is around 0.704 it is. So 70% of the 70.4% you can say that the probability of the email actually spam, given that it is also classified to be the spam, suppose. So this is what the understanding. So with this we can identify where you are using the total probability, where you are using the Bayes theorem. I hope you could understand well. Thank you so much.